All right, let's talk about probability when it comes to area. So if we look, an art class painted a mural on a wall of their school. The first thing the class did was outline the area of the mural, um, was going to cover and paint the background of part of the area as shown. So they're going to paint this part. While the paint is drying, a fly lands on the wall inside of their mural's outline. What is the probability that the fly landed in an unpainted section? Use 3.14 for pi. Write your answer as a decimal rounded to the nearest hundredth. Okay, so there's a fly and it lands somewhere. Maybe it's landing in this non-painted section here in the middle. Maybe it's landed here in this painted section. We've got to assume that the fly has equal likelihood of landing in the painted and non-painted sections. So what we're going to do is we're going to divide the area of our success, which would be the fly landing in the unpainted section, divided by our total area. Okay, well, the area of the unpainted section is the area of this small circle. Now, if it's 10 feet in diameter, it's 5 feet in radius. So that's going to be pi r squared for a radius, which is, they said use 3.14, 5 squared. And our total area, well, our total area would be the area of the entire circle. So I would want to find this radius. Now, if I know that this whole thing is 34, half of that is 17. So again, I'm going to find the area of a circle, which is pi r squared. So I'll take 3.14, and I'll divide it by, and I'll multiply by 17 squared. Ooh. Sorry, that decided to jump around there. 17 squared. So let me plug that into my calculator and see what our chances of landing in the unpainted region are. And if I plug this fraction into my calculator, it gives me a decimal equivalent of 0.0865. It says to round to the nearest hundredth. So the nearest hundredth is this 8, and will the 6 make the 8 round up or stay the same? It'll be 0.09. A company was sponsoring a holiday egg hunt and decided to paint their logo on the field where the event was being hosted. What is the probability that an egg with the grand prize ticket inside was placed in a section of the logo that was not painted? Write your answer rounded to the nearest hundredth.
Good afternoon, Jaguar. Just a few announcements before we begin.
Sorry about that interruption. Okay, so we need to find the chances of being inside the not painted area. So we need to find the area of that triangle and divide by the area of the rectangle. So let's talk about the rectangle first, because rectangles are pretty easy. Length times width, that's going to be 22 times 14. Now, it might be difficult to see here, but if we have that vertical distance of 14, then, well, this would be 14 over here, and wouldn't this distance here be 14? Well, then that makes that the height of our triangle, and we already have our base of 22 for our triangle. So triangle area is 1/2 base times height, so 1/2 base of 22 times our height of 14. And then I start to think to myself, wait a second. So we have 1/2 times the product divided by the same product. So won't these just cancel and we'll get 1/2? And that is indeed the case. Oh, but it says it wants it rounded to the nearest hundredth, so 1 divided by 2, 0.5. If you want, you can plug it into your calculator, but every time you just have a triangle is going to make up half of the area of the rectangle with the same base and same height. A company logo, a company was sponsoring a holiday egg hunt and decided to paint their logo on the field where the event was being hosted. What is the probability that an egg with the grand prize ticket inside was placed in the section of the logo that was not painted? So again, that's going to be this white area. So we need to find the area of these circles, and we're going to assume that they are congruent. Otherwise, this problem is impossible. Now, if they're congruent, then that means this being 22, this is 11, which gives us a radius of 5.5. So I'm going to say I have two of them times 3.14 times so pi r squared, 5.5 squared. So 3.14 times 5.5 is going to give me the area of one of the circles. I'm using the 2 because I have two of them. And I'm going to divide that by the area of the entire rectangle, which is 30 times 22. That's going to give me 0.2878, blah, 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 rounding to the nearest hundredth. I got this 8 here. The 7 will make it round up 0.29. A stained glass window was designed and stained as shown below. It was found that there was a single tiny air bubble in the glass. What is the probability that the air bubble was in the unstained area of the windows? That means there might be like a little air bubble here, a little air bubble here, but we want to find the probability of an air bubble being in this area. So we're going to take the area of the small rectangle, which is base times height, so 19 times 34, and the area of the entire figure, which is base times height, 24 times 37. And that'll give us our answer. So 19 times 34 divided by 24 times 37. Oops, my calculator gave that to me as a fraction, 323 over 444. I can convert that to a decimal by just doing division. And that's going to give me 0.72747 and so forth. We want this rounded to the nearest hundredth. So this 2, hey, that 7 will make the 2 round up. So we'll have 0.73 as my probability. What about this one? It says, find the probability that a point chosen at random from the image below will be a point from the unshaded region. Okay, so we want to find the chances that we pick a point inside the circle. Well, that's a square around a circle. Its diameter is 24, as we get right here. So its radius is 12. So we'll have 3.14 times 12 squared divided by 24 times 24, because that's the area of the entire figure. That's going to give me 0.785. That terminates there. We want to round it to the nearest hundredth. So again, we look at the 8, the 5 will make it round up. So we'll have 0.79 as my final answer. That's probability with area.